Well, good evening, ladies and gentlemen. This is April the 28th, and we're going to be uh, looking at a lot of different things tonight. I guess, first of all, let's talk a little bit about the test that you took this past week. Um, I got grades out to everybody that turned the test in, and I sent it by email to each person. So hopefully those got to you. Um, Michaela, to answer your question, I went back and checked. I actually sent it twice to you. I was not. I was concerned that the first one didn't go through, and so I sent it twice to you. And if you still didn't get it, I can tell you later. Um, on that test, there were some things that I'm sure you're going to kick yourself that you didn't catch. For example, on number one, the very first question, I believe it's the first question. I ask you who discovered the structure of DNA and when they did it and where. That's three things. And lots of people only put two. So there each thing that you put, each answer you put counted a point. And so if you ended up missing 10 things, you got a 90. If you ended up missing 15 things, you got an 85, and so on like that. Um, there were also some very curious that some folks just didn't answer. Um, More than one person just didn't answer some things. For example, there were two or three or more people that did not answer the very last question on the test. Um, I, you're you're just going to have to watch those things. This is the kind of test. I'm not there standing next to you. You can ask questions, and you've got time that you have to do this. And speaking of which, we're going to change things a little bit. I received an email saying that I had to have the senior grades for high school. Okay, now I want you to understand something very carefully. Those of you who are seniors, your grade is going to be turned in Friday. Okay, that does not end you having to do things for your college grade. I know that stinks, but that's just the way it is. Now, I think if my memory serves me correctly, I've got an email. I tell you, I get probably in some cases 20 or more emails a day. So I'm trying to remember all of them. But I think Cleveland State sent me an email saying I believe our grades have to be turned in either the 11th or the 13th of May, and I think it's the 11th. But anyway, um, that means that everything is going to be ending um, in the next not even 2 weeks. Okay, and so we're going to have one more test that is going to be given out. Okay, I want you to understand this, and this is different. And I'm going to send an email to everyone that this test is going to be coming out by midnight Wednesday night. Midnight Wednesday night, and it will be due midnight Thursday night. Now, the reason I'm doing this and changing it up a little bit here is that I have to get grades in by Friday. And so this will give me a chance to grade these tests and include them in your final grade for the seniors. Okay. Now, um, I'm going to be putting grades in the computer then from now until Friday. And so um, if you have Parent View, you can look at those grades. I'm not going to send you a final grade until I have all those things in. And the seniors in particular, I can probably send them something. Maybe I can send all. I mean, it just depends on how much time I've got, guys. So things are kind of cranking up and getting fast and furious here. So again, that next test will be given to you by midnight Wednesday, and it will be due by midnight Thursday. And I'm going to be sending probably an email out tonight to refresh your memory on that, make sure everybody gets them. And I hope that all the email problems are solved now. You understand you've got to keep checking your Cleveland State email account. And some of you have given me other emails. I'm sending it to all of them that you've given me, plus the Cleveland State one. So hopefully I have all of those, and you're going to receive several reminders since this is a change. Okay. Again, this is just give me a chance to get those graded and put them in the system Friday so that I can send Miss Brown, post your grades by Friday and get those to her. Now, that doesn't mean, I want you to understand this as clear as I can make it, that you, in terms of your college grade, things don't end. Okay. Now, not all of you are taking this for college credit. I understand that. For those of you who are taking it for high school credit only, basically, this next test is it for you, and that's it. Now, the other thing is that you need to keep getting these assignments in. These assignments count as quiz grades. Okay, and I've sent some emails out to people. They have multiple things that they have need to get me. All of you need to answer all the questions that are on the first ecology handout I gave you on abiotic factors, and also on the questions. You have several things you have to fill in. On the second one, the ecology that says biotic. Okay, and you got to get those to me by Thursday. By Thursday. Wednesday would be great, but you have to have everything in by Thursday so that I can make sure that I've got it on the computer. Okay, now I hope I will just say, Caden, that it is due Thursday. That's fine. I mean, I'm not sure. I don't remember. I've sent so many emails out. I don't remember if I set a deadline on that or not. But we're just going to say Thursday, and that would do it. Okay, and that everything has to be turned in by Thursday. Now, after Thursday, and we have that test and everything's done on that, I want you college students to understand you're going to have at least another week of some assignments. We're going to be doing some things on plants, and you're going to have to then have a final exam. Okay. Now, the final exam is going to be, my thinking is right now, either the end of next week or the beginning of the next week. Now, I believe today is the 28th. We will, if I remember correctly, there are 30 days here. So tomorrow's the 29th, the Wednesday, 30th would be the Thursday, and the 1st of May would be on Friday. So we're looking at probably not this coming Friday, but the next Friday having your final exam. And again, it'll probably be about a 24-hour time that you get to take that. Dana, as far as your posted grade, I will have to email that to you. If you don't have parent view, now I'm going to be, like I say, I'm going to be putting grades in the computer tomorrow. I'll be putting grades in the computer Friday morning. And so your final grade for those of you who are seniors who are not taking this for college credit will be available probably by, say, I'm just guessing here, around 10 o'clock noon on Friday, somewhere in that neighborhood. So that's the best I can do. I don't like the idea of sending you an email with your grade on it, but that's the only way I can do it if you can't get parent view. And there are going to be folks at the office at the school tomorrow and Thursday, tomorrow and Thursday, if you need to call them and seniors asking, excuse me, I may have to go get a glass of water. If you need to call and ask anything about parent view or anything like that. Um, I tell you what, I'm gonna go get a glass of water. If you have any friends who are not watching this, they need to be watching this. Make sure they get all these announcements. Excuse me, just a minute. Sorry about that. I hate that having to live stream like this. I'd rather be talking to y'all in person and seeing your faces and hearing your questions. And that was always a joy to me in the school day. Y'all are a good bunch. Um, Now, as far as what's coming up in terms of the test on uh, Wednesday at midnight, we'll be over the packet that is. I know you can't see this, but the ecology notes, abiotic factors, and hopefully you are going to very quickly go through and fill out the answers. Um, there's a few minutes here. If you have something that you have to ask about that, then that's fine. The test is going to be a very similar format. Um, I'm thinking of making it a little different in terms now I had a variety of ways this was sent to me. Some folks typed out the answers, and that was really great. Some folks wrote them out and they took a photograph of them, and that worked. Um, but I'm going to try to cure this business of maybe making it a little clearer. I hate to get very elementary with y'all. Your college students, your high school seniors and juniors, and I kind of hate to just say, hey, this question has three answers to it. When you read the question, it's very obvious it has three answers to it. So anyway, and sometimes they say this question had four. It says four, and sometimes folks didn't put down all four answers. So we'll see. We'll see. I may try to make that a little clearer. The format's going to be very similar to what you saw last week. Um, I may add a few twists and turns here and there and change some things a little bit. But again, you can use your notes, you can use your book or a book. All I ask is that you don't look answers up on the internet and that you don't ask someone to help you with a question. So if you have any questions, now is the time to ask them about that handout. Anything you want to ask. Now, for example, um, I may have you answer some questions about latitude and longitude. So you need to have clear understanding of what those things are, or you need to have it written down well, or look it up in your book or on the handout that we've got here. Can we consider the internet a book? No, you can't consider the internet a book. You have to use a book that you've got in your hands. Now, I don't know what to tell you if you don't have your book with you and you want to call the school tomorrow or and ask them, can you get my book out of my locker and bring it to the outside of the school? I can't do that, but maybe they can. It's not going to do any harm to ask. Probably it won't do you any good, but uh, ask anyway. I mean, what harm can it do? Um, but anyway, you can use a book, or you can use your notes. You can use your handout. Any of those things uh, would be fine. The agencies, that's all clearly written out for you. You looked up the various symbiotic relationships and habitat requirements, habitat range, territory. Those are all pretty straightforward things. Atmosphere, lithosphere, hydrosphere. Again, always, pretty straightforward. There's not a lot of things you have to fill in here. Um, Clouds are made of ice crystals and dust, and when two cold and warm air mass meet each other, what happens is precipitation. And just things that, guys, you got to take the time just simply to look these things up in your handout and in your book. Um, Index, or the, I should say, the glossary may be a place to go to in your book. Um, the index, where you look up things, that could be a place to go. But don't do a half job. And most of you did pretty good on the test that you took, so hopefully that'll be okay for you. Won't see any questions, so we're going to move on. Um, the um, Are you going to give us supplemental material like for the last test? No, what you got is what you got. That's it. There's no other materials that I'm going to give you. That's all I've got. Okay. So sorry, Lauren. That's again. You can look up things in your book. Of the ones that are listening here, about how many of you don't have your book with you? Would there be 3, 4, 5, 6, 7? Did most of you leave your books at school? Well, I guess hopefully, now you could borrow a book. Okay, Caden's got hers. Felix has me. I don't know if me means he's got it or he's not got it. Me got it. Me don't have it. What do you need there? What are you saying there? Anyway, um, you could borrow a book from someone. I mean, if you want to work out something like that, Felix says no book. Okay. Um, the supplemental material, if you were here for the lecture last week, the supplemental material is this handout is pretty complete. Now you can look on the internet to answer questions to your heart's content, but once I give you the test, then you need to. That's it. You're going to have your supplemental material is in that handout. Now, if you want to, they're like Khan Academy. You go to YouTube. There's several places you can go to listen to folks um, talk about these kind of things. And so, if you want to do that, that's fine too. Now, question was, will you be going over the biotic ecology notes in this video? Now, I am going to go over those right now. So I'm assuming that there's no other questions about the abiotic. We're going to go over biotic. First thing I would suggest you do, if you have them written in a printed form, which I don't know if you did that or not, but what I do is I'll simply put a number on each page, and then I can refer to the page. And this is just what I would do if I were lecturing in class. And so in looking at page 1, one of the things I'm going to have you do You see there, thing we're talking about population is we are going to be looking at some figures. For example, if you look over on page 2, page 1 mentions carrying capacity. What is that? Well, the written definition is that carrying capacity is the number of individuals in a population that an ecosystem will support indefinitely. The number of individuals in a population that an ecosystem will support indefinitely. That's carrying capacity, and that's on page 1. Now, there's a lot of things that go along with that. For example, there is a figure on page 2 that shows carrying capacity. And one of the things you're going to have to do is to be able to look at a figure like this and evaluate it. And one of the things that you're going to have to do is pick out where the rate of growth is fastest. And the rate of growth is fastest where the curve is the steepest. And you'll see in the figure on page 2, it's an S-shaped curve. And so it starts out and gradually goes up. And where that curve is the steepest, that's what we call the exponential growth, or sometimes called geometric growth. That's where the growth rate is the fastest. And then it levels off. And when it levels off like that, that leveling off at the top is, in the coronavirus, they keep talking about flattening the curve. And so that leveling off, or that flattening of that curve, is what we call the carrying capacity. Okay, so that is that's something that you can read, so to speak, and tell me some things about that. Now, what causes the growth to go in an exponential curve? What causes that? Well, that means that whatever organism you're talking about has everything it needs. There's nothing limiting its growth. Now, what kind of things could limit the growth of a population? So if you look at page 1 again, it says factors that can decrease a population. Now, it's not necessarily you look just at decrease. It's a little misleading to say that, but basically that's what we're looking at, things that are going to slow the growth of a population. Stink bugs flying into my hair here. I don't know about y'all. We have bugs all over the place. But when the population is going up, now human population right now is going up and is in that steep area. Okay, it's not leveled off. Human population would be what we call a J curve. The shape of the curve is a J. Okay, and what kind of things might cause it to level off would be what we're experiencing right now: disease. Now, if we all know about social distancing. What does that mean? Well, it means the density of people in an area is less than it normally would be. We spread out more. That means our density is not as much. Well, and the reason for that is that whenever you have something like disease is worse when the population is higher. So we call those things like disease and like competition population dependent factors. And there's a place there for you to write population dependent growth factors. There's a blank after it. It simply means that whatever factors you're talking about, the factors are dependent upon the population, the level of the population, how large the population is. And mainly they get into density a lot. And examples would be competition. Another example would be disease. Okay, all those things are things that depend upon the density of population, or how large the population is. Now, the next thing is population independent growth factors. These are things that have nothing to do with the population size. For example, we're going to have a storm probably tomorrow morning. It doesn't matter if all of you and the whole Tellico Plains High School, or even the whole town of Tellico Plains gathers on the football field. It's not going to have anything to do with that storm. It's not going to make it worse. It's not going to make it better. It is a population independent factor. So natural things like weather and climate, natural disasters like a tsunami, or like a hurricane, or like a tornado, or like an earthquake, or a volcanic eruption. None of those things have anything to do. They're not going to be worse. They're not going to be better in terms of the population of individuals in the area. So they are population independent factors, factors that have no relationship to the size of a population, factors that have no relationship to the size of a population. And again, all those examples are basically natural type things, natural disasters, climate, weather, all of those things are what we call population independent factors. Um, Competition is rather unique. That's one of the things that's on the first page as well. Interspecific competition and intraspecific competition. Competition is where you have organisms competing for something, okay, some requirement. And so interspecific is competition between two different species. Like if you had a black bear uh, eating acorns, and a deer comes along and eats acorns, that's interspecific competition. Intraspecific competition is competition within a species. Now, which one's the worst? I mean, or which one's the most intense? Which one is the greatest competition or the most competition? Well, the most competition is going to be dependent upon whether the organisms are in the same habitat, number one, and also whether they have the same niche. Okay, what's habitat? Habitat, remember, is where the organism lives. What's niche? Niche is the job, the role that the organism plays in an ecosystem, whether they're a herbivore, whether they're a carnivore, whether they are a decomposer, or whether they're a primary consumer, whatever they may be. And so competition is going to be the most. Now, here's the key. It's not in your handout there. The key here is competition is going to be the most in intraspecific within a species, because a dog's going to compete more with a dog than they will with a bird. Okay, because they're the same species. They have the same needs. They have the same habitat. They have the same role in an ecosystem. Okay, and so competition is something that is most between individuals of the same species. Now, we often think of competition as fighting. Fighting is counterproductive. Fighting is not as common in nature as you think. And when you look at territory and range, if I say where do I find um, a black bear, and black bear could range, and use the word in the sentence here. Black bear can range all the way from, say, northern Alabama, Georgia, and certainly northern Georgia, South Carolina, North Carolina, and going up into Pennsylvania, and so on and so on. And just tell me where I might find black bear. But now, in terms of territory, territory is the area an animal will defend. Territory is the area an animal will defend, and it's usually during reproduction. Okay, usually during reproduction. Got the old turkey out there, that he has hens, and the old gobbler, he hears another gobbler nearby, and I've told you the story in the Smokies where I made it sound like a gobbler, and I had one out in the field out there, and he just immediately started displaying, and then he's big stuff. Okay, he wasn't looking for a fight. His display was for him to discourage me from coming through, coming out there. And so that's his way of establishing his territory. And so many times that's the way territory is actually established instead of having fighting. Okay, so back to the figures. You look on page 2, and there's the J curve. You see that, and it looks like a J. The S curve looks like an S. Now, what causes it to flatten out? Flatten out. Then the resources that the organism, therefore, um, that if you run out of things that the organism needs, then the population is going to not grow as fast. That's the flattening of the curve. Okay, that's that very top of the curve. Now you'll notice at the bottom down there, there is another graph. It's called a cyclic population uh, curve, and this one's on about a 9 to 11 year basis. And they show two things there: snowshoe hare and Canadian lynx. Canadian lynx is like a bobcat, and the Canadian lynx eats snowshoe hares. So whatever the snowshoe hare population does is going to determine what the Canadian lynx population does. And so about every 9 to 11 years, the snowshoe hare population is going to go up, and then it goes down. Okay, why it does that, we don't know. If you go over to the mountains around us, east of eastern mountains, there's ruffed grouse. Ruffed grouse does the same thing. About every 9 to 11 years, population goes up, and then it goes down. Why? We don't know. There's no clear answer to the question of why. But that's a cyclic population. And you go to page 3. I'm looking at, well, the top graph. Don't even worry about it. But the bottom one is a larger representation of the S curve, and it gives you a little more information. It clearly points out where the exponential part is. And remember, exponential is the place where you have the greatest amount, or the fastest growth in the population. The rate of growth is increasing. There is another way of putting that. Okay, and again, as it gets to the top, that transitional phase, plateau phase, is the carrying capacity. Okay, this is the most common population curve that you will see in nature by far. This is the most common. Okay, this is the most common population curve that you will see in nature by far. This is the most common. Okay, simply being able to read that. Where is the fastest growth? Where is the carrying capacity? Okay, and you look at things about a population. Where would you expect the birth rate to be the highest compared in terms of death and birth? Where would you expect the birth to be the highest and the death to be the lowest? And that would be when the population is growing the fastest. Now, we also look at things like immigration with an E and immigration with an I. We mentioned this last week. Immigration with an E is where individuals are leaving a population. Immigration with an I is, remember, where individuals are coming into a population. Remember, we said the United States has the number of kids per family is less than 2. Well, that normally means that the population is going down. It's decreasing. But since we have a lot of immigration, individuals coming in, then our population is going up. Germany used to be, they were losing people. Their population was going down because people just weren't having enough children. Now, in the last, say, 20 years or so, Germany has had a lot of immigration, individuals coming in. So now their population is now at least stabilized. It may actually be growing. Japan doesn't like immigration, and their population is going down, is decreasing, because the number of children per family is less than 2, and they don't want immigration, so their population is going down. Now, anything that really changes the ecosystem is going to change the number of individuals it can support. again, depending on what their habitat requirements are. Last week we mentioned that black bear like to spend their winter. The female likes big hollow trees. She crawls into them. She has her cubs in there, our cubs, and that we think is a determining factor of where you find black bears in an area. And so if we cut all those trees, we've eliminated some of the shelter for the black bear, and so the black bear numbers would go down. Okay. So anything that you do to an ecosystem that's going to change it is going to change the number of individuals in that ecosystem. And so this gives wildlife biologists a way to manage populations of things. If, for example, if I want to increase the number of trout in North River, what might I do? Well, people who fish for trout know that a lot of times that you go to a pool, you go to a big hole, and trout are going to be laying down in there, and in the bottom of that hole, they're going to be at the base of the falls, and all these kind of places where people like to fish. Well, why don't you create those things in a river? In North River, I can remember years ago, I was leader of a crew of high school kids and kids that had just graduated high school. And one of the things we did, we worked on fish structures in North River. And it's a nice job. We would go out there and then put big rocks and form a dam. And nowadays they say don't do that. We did that. And that the idea was to create like artificial pools or artificial waterfalls, and that this would help the number of fish. Now, there's some questions on page 3. It says, when are the growth factors having the least impact on the population growth? And could we rephrase this by saying that resources that are used by the population are not limited? Now, when resources are not limiting growth, growth is occurring. That's what that's saying. And so you would find that in places where a curve is going up. Okay. When it levels off, then resources then become limiting. Why? Because they're not infinite. Okay. Another one there, when are the limiting population growth factors having the most impact on the population growth? That leveling off, that what we call the transition phase, that's when they're going to have the most impact. At what point would we say that the population is at carrying capacity? And that's that again, that where it levels off the top up there, that's the plateau phase. And would carrying capacity change if the area had a prolonged drought? And the answer is yes. Again, any time you have a change in the ecosystem, then it's going to affect population. Sometimes it makes a place where populations, like you say, well, people hate clear cutting. And in the 60s and 70s, let's get rid of clear cutting. Well, they found out if they didn't clear cut, deer populations went down because deer like disturbed areas. And so, if you change the ecosystem, some animals, thinking just in terms of animals, some animals are going to be benefited, some animals are not. And so it depends on what their habitat requirements are. Remember again that plants require light, water, and minerals. Animals require food, water, and shelter. Those are basic things you have to know. On page 4, I'm looking at is human population growing at an exponential rate? Yeah, yes would be the simple answer there. What would slow this rate of growth? Now, right now, you got an example of it. Disease could slow it. War could slow it. Now, in 1918, really, I think 1917 through 1919, upwards to 50 million people died with the Great Flu epidemic worldwide. Now, the world population was way less than what it is now. World population now is about 8 billion people. At that time, the world population was probably somewhere between 2 and 3 billion. And so a number of 50 billion people dying is a tremendous number of people. Now, I understand even what we're having in the United States with possibly 70, maybe possibly 80,000 people dying, would be that's terrible. One person dying from this is terrible. But consider if you had 5 or 6 million people dying in the United States, then you can see what happened in that time. Sex ratio, polygamy. Polygamy is where you have a sex ratio that is not equal. Generally speaking, we're talking about one male to some number, 2, 3, 4 females. That's polygamy. Monogamy is where you have one male, one female. Went down to the pond that's down the hill from the house here about 4 or 5 days ago, a week ago, and there were 2 geese down there, obviously a male and a female. Geese mate for life, and that's monogamy. Okay, and so it's a 1-to-1 ratio, sex ratio, and so then doubling rate. There's a term there called doubling rate. How many children must a couple have in order to replace themselves? 2. If you got 2 people, in order to replace themselves, they got to have 2 kids. And so if the average number of children is less than 2, a population is going down. If the average number of children is more than 2, the population is going up. Okay? Generally speaking, developed countries are usually have a lower population growth than undeveloped countries. Generally speaking, that's just kind of a general rule of thumb. Now, doubling rate means how fast a population will double. Generally, and again, this can change as our world changes. This can change. Generally speaking, the doubling rate of humans has been somewhere around 40 to 60 years. And as you get into more and more developed countries, growth rate tends to go down. Okay, and so that would make the doubling rate that much longer in terms of number of years. But generally speaking, I can remember when I was in high school, it's been a long time ago, that's been in the 60s, late 60s, that we considered the population of the world being somewhere between 3 and 4 billion people. You can see it's taken this long for it to double. Children per couple, again, that's getting into if it's the number of children per couple is greater than 2, then the population is usually considered to be growing. Now, on page 5, at the top there, we're not going to worry about those actuary tables. So you make a note to yourself. You don't have to memorize or study those or anything. But the survivorship curves, that's something that we need to spend a little time on. Look at type 1 survivorship curve. That's where the young are here, and then as people get older, they drop off. What that means is that we are very protective of young children, and so generally speaking, they're going to slowly. Out of 100 children, by the time they get into 50 years old, some have died. I understand that. But then it reaches, say, their 70s, and most of them die in their 70s and 80s. And so that's the reason for that curve. That's what that's talking about. And so the type 2 in birds, being a constant curve, that slanted curve like that, simply means that birds are dying pretty much at the same rate, no matter what age they are. And then with trees, you'll notice that, again, you have this steep curve from the very young trees die off in massive numbers. And then once they reach a certain age, then they don't die very fast at all. Okay. It's like at a house I used to live in. There was a big maple tree in the back, and it had these little helicopter seeds, and they'd fly all over the place. And then in the spring, they'd sprout up, and you'd have literally hundreds, maybe even thousands of little tiny maple trees. And obviously, they didn't live. And most of them, they just died out. It didn't hurt. It didn't help them any that I ran over them with a lawnmower. But here again, that's generally what happens to the young like that. Um, the last page, population density is just referring to the number of individuals per a certain area. Number of individuals per a certain area. That's all that's referring to. Now, the last thing there is going to be a little hard to get in your mind. If you've got some paper there, and draw 3 boxes. Just draw 3 boxes. Now, uniform is where you take one of those boxes and you put little dots in a very even pattern in that little box. And each dot is an individual, whether it's a plant or animal, whatever. But each dot represents an individual. That's uniform. Say, well, no, but nothing has like that. Well, yeah, they do. Desert plants will. Desert plants will grow almost at a certain even distance from each other. Why? Because when they set out their roots produce chemicals which tell other plants, don't grow near me. Why? Because there's a limited amount of water. And so that plant is basically staking out that area for its water. Now, if you were to take an aerial photograph of this, it would look very even. They're very uniform in their distribution. It's called distribution. Now take one of the other boxes and put dots, about 5 or 6 dots right next to each other. In another place on that square, put 5 or 6 dots next to it. And that's clumped. Why? Well, think about it a minute. If you're a desert animal, you're going to have water. Many desert, and I understand some desert animals, they get water from the things that they eat, but others have to drink water, and so they're gonna kind of congregate around water holes. That's clumped. That's where they find the things that they need. In the American Midwest, like in Illinois and Indiana and Ohio, early settlers coming into those areas would look for beech trees. Why? Because beech trees require very good soil. And so they knew whenever they found beech trees, grove or something like that, hey, cut the beech trees down and have their farms there. And so you go through the Midwest and you run into towns called Beech Grove, Beech Center, Beech Village, and they recognize what they were looking for there. Random is just where you have random dots just randomly all over the little box. Okay. And that is random is can be found in nature. I mean, if you again go back to the maple tree I was talking about, it sends out these seeds just everywhere, and wherever they land, that's where they sprout. And there's nothing they're not when at very early stage like that, it's just a random distribution. Now, as time goes on, those that are in very poor places are going to die, and those that aren't, the ones that are in very good places are going to thrive. So that, again, it boils down to, as time goes on, that they become clumped in those places where they can get the requirements that they need. Okay. Have you run across any questions here? Now, here's the way this will probably work. We'll have this test on Wednesday. Again, you're going to get the test by Wednesday midnight, and you're going to have to get it back to me by. That's going to do it for those of you who are seniors for your high school grade. Okay, and in terms of your high school grade, we're going to go ahead and say that's going to do it for all of you for your high school grade. Okay, for your college grade, you're going to have at least one more test, and it'll be over the biotic handout, the one that you've got most recently. Now, you're going to have another 1 or 2 assignments coming up next week, again, for the college students. 1 or 2 assignments coming up next week having to do with plants, and those will be counting as quiz grades. Okay. If you don't do them, that gives you a 0 on that. If you do them, then obviously most of you are going to get a good grade out of that. Okay. I'm about talked out. I went a little longer than what I usually do. Do you have any questions? Again, when you get this test Wednesday at midnight, and I may get it to you an hour or two before that. Depends on how long it takes for me to make it out. But by Wednesday midnight, then it's going to be due midnight on Thursday. When you get that, again, you can use your book and you can use your notes, use the handouts that you've got. Now, I'll tell you what. Felix, you say you don't have a book. Call the school tomorrow and see what they can do for you. Maybe they can get yours out of your locker. Is it in your locker? If it's in my room, again, I can't help you. But see what they can do. And if anybody else doesn't have a book, then you can call them and ask them. I mean, things are getting a little more relaxed now, so maybe they'll do something for you there. That could help you with this test and help you with the next one as well. Okay. Does anybody have a question? Well, I hope everybody is well. I hope y'all have a good evening, and that will do it. Thank you.